I wish you a wonderful day and welcome to the OXL YouTube channel. In this video, we will talk about how we can implement a network-wide DNS-Cache on our Linux network firewall. Why would we want to implement such a cache? Why would we need to do so? Some filter methods like DNS-Resoved variables and web filtering with a proxy like Squid in transparent mode require us to ensure that the client and firewall resolve a DNS record to the same IP addresses. In practice, this is not really possible anymore as cloud service providers use a very low time to live in their DNS records as they use them for round robin and load balancing and so on. How will we implement such a caching service? We will implement a very basic caching service. You could, of course, also implement a fully fledged DNS server that can handle caching and overrides and so on. We will use Systemd-Resoved in our case as it is very minimal and exactly what we need for our setup now. Okay, now let's just showcase what the actual technical problem is we run into. Here we perform a DNS lookup and we can see this is the IPv4 address we get back. If we perform multiple lookups, we can see the IP address changes very frequently. So if we perform a DNS lookup on our firewall system that is creating a DNS-Resoved variable we are using in some firewall rules, we will get many false positive drops as the client wants to connect to other IPs. Yeah, so let's get started. We will install the Systemd-Resoved package here. We are on Debian, therefore we use the apt package manager. Okay, so far so good. We have a very simple configuration. I'll just paste mine in there. And this is it. We will use Cloudflare DNS servers in this case, the .2 servers, so the ones that have malware filtering built in. If we don't use or apply DNS blacklists on our firewall, this is an option to get a little bit more security. But yeah, we will use DNSSEC if possible and also DNS over TLS if possible. We want to cache the requests and we want to start listeners, DNS listeners on localhost and all other IPs our firewall has. We do not want to resolve our etc hosts records as this might give up some information about our system to clients and so on. We would not want to leak those. Yeah, and we disable the NR listeners as we do not need them. So let's restart and enable Systemd-Resoved. It was already enabled, okay. So let's check out our listeners. We see some DNS listeners here. Here's the one listening on all of our gateway IPs and so on. And the internal one. Okay. Let's jump into our NFTables config. We will redirect all DNS queries that are passing through our firewall. So all DNS queries that are performed from our clients, servers and so on in our networks. We will redirect all of those to our DNS cache to enforce that cache on all clients. So we can do so using destination NAT We'll see that in a second. Here is our main configuration file, the test.conf, and here we have includes for our firewall components, so to say. Yeah, I already have added a component for our DNS-Config. We will also move that host DNS to our DNS-Config. And here is our DNS-Config that I have prepared. So let's take a look. We have a variable containing our DNS servers that we want to use for our resolver or our cache. Then the user that is running our resolver service, our cache service. After that, we have a chain that performs destination NAT. Here we will redirect all DNS requests from the firewall itself to the DNS cache if they are not already from the DNS cache. If they are from the DNS cache, we do not want to destination NAT them. And then, of course, the rest of our internal network will also get redirected to our cache. Okay, we can look on the input and output filters. We need to allow private networks and our firewall itself to query the DNS cache, the DNS resolver. And last, we also need to allow outbound traffic from the firewall to the firewall, and of course from the resolver to the internet. So we allow DNS over TLS and basic DNS to our configured DNS hosts if the source is the resolver, the cache resolver service. Yeah. As we do not have hooks configured in these chains, we will have to reference them. The input DNS cache will be referenced in the input chain that has the input hook, and the output DNS cache will be referenced in the output chain that has the output hook. And of course, where the magic happens, so to say, we have the destination NAT for the DNS cache. We here have two chains, the output destination NAT and the rerouting destination NAT. The output destination NAT is for traffic that is originating from our firewall itself, and the pre-routing is for traffic that is coming from our network to our firewall. Okay, let's check the config. Yeah, it's valid. Reload it. And our DNS cache should be enabled. So, now let's test it on our client. We perform a DNS lookup. The IP is not changing that frequently. Let's also perform a DNS lookup on our firewall. And it's working. If we override the DNS server, we still get the same IP, so we still get redirected to our cache. Exactly what we want. Of course, also, if we perform some DNS lookup on another DNS server IP, it will also get redirected to our DNS cache, as we have implemented a DNS cache or destination NAT. Yeah, that's basically it. Let's just check out the resolve CTL, the command line utility for it. Here is some status. A little bit more interesting are the statistics, where we can see how many cache hits we had and so on. Yeah. We can also perform a query using this resolve CTL and get some more information from it. We can see the time it has took to perform the query. In this case, it was the first time to query this DNS record, and thus it was queried from the internet. Second one, second time is a little faster. Here we also have the information if the DNS query was encrypted or not. So it seems it also uses DNS over DLS already. We can also flush the caches. Flush it again and we'll see. Now it took longer. Yes. And also interesting, we have a live monitor where we can see all the DNS queries that are hitting our resolver. Here we can also test if we try to override the target DNS server with some other IP. We see the request also hits our resolver because, of course, we have configured the catch-all rule. Yeah, that's basically it. I hope it was informative. If you have some feedback or some idea on how to improve that implementation, write it down in the comments below, and if not so, have a nice day and servus.